Hello friends, my name is Bhavesh and welcome to our YouTube channel. Yes, our YouTube channel. Okay, so last time we are discussed about PMDC motor. Okay, the types of DC motor, and first we are discuss about previous video, permanent magnet motor. Okay, so today we will discuss about in this video uh, separately excited motor, series wound motor, shunt wound motor, and compound wound DC motor. Okay, so starting with in this video, we are discuss about separately excited DC motor. Okay, so we are start with this figure, and this is figure. Okay, so uh, this uh, this motor have field coils similar to those of shunt wound machine. Okay, but the armature and field coils are fed from different supply source as showing in figure. Okay, and may have two different voltage ratings. Okay, I'm write this. Please see in this video. This motor have field coils similar to those of shunt wound machine, but the armature and field coils the armature and field coils are fed from different supply sources. Okay, different supply sources. Okay, as shown in figure. Okay, they have different voltage rating, different voltage ratings. Okay, uh, in this motor in this motor means separately excited DC motor, armature current means IA is equal to line current line current line current. Okay, IL line current is equal to I. Okay, and back EMF develop EB. Okay, EB means back EMF. Okay, back EMF EB is equal to V minus IRA. Okay, armature armature resistance. Okay, and the third is power drawn from supply mains. Power drawn from supply mains means P is equal to VI, where V is supply voltage, V, okay. And fourth is mechanical power developed, mechanical power developed means P M, okay. Mechanical power is equal to power input to armature, power input to armature minus power lost in armature, power lost in armature, okay, is equal to Vi minus I square Ra is equal to I in bracket V minus I Ra bracket complete is equal to Ebi, okay. This is complete, okay. So separately excited DC motor here we showing in figure in this video. This is theory and this is formula. This is theory and this is formula, okay. Okay, so next motor is series wound DC motor, and here is a simple figure, okay. So theory is as the name implies, the field coils consisting of few turns of thick wire are connected in series with armature, okay. uh, is showing in figure. The cross sectional area of the wire used for field coils has to be fairly large to carry the armature current, okay. But owing to the higher current, the number of turns of wire in them need not be large in DC series motor, okay. So I am write this, the name implies the field coils consisting of few turns of thick wire are connected in series with the armature as showing figure. The cross sectional area of the wire used for field coils has to be fairly large to carry the armature current, but owing to the higher current, the number of turns of wire in them need not be large in DC series motor
ఇంకా చెప్పండి.
okay. So series 1 DC motor, the name of implies the field coils consisting of few turns of thick wire are connected in series with the armature as shown in figure. The correct cross-sectional area of the wire used for field coils has to be fairly large to carry the armature current, but owing to the higher current, the number of turns of wire in them need not be large in DC motor. Okay. 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 Formula: armature current IA, armature current is equal to series field current ISE. Okay, series field current and is equal to line current IL. Line current is equal to IE. Back EMF develop EB, back EMF is equal to V minus I is equal to okay, back EMF develop EB V minus I RA, armature resistance, and RSE. Okay, RSE. The proper power drawn from supply mains is equal to VI. Okay, and the mechanical power developed in PM is equal to power input minus losses in armature and field. So formula is equal to VI minus I square RA plus RSE. Okay, and I in bracket V minus I internal bracket RA plus RSE in complete the all of bracket is equal to EBI. Okay, EI. Okay, so the armature current IA, series field current ISC. Okay, line current IL, I is equal to I बराबर. Okay, back EMF develop EB V minus I, armature armature resistance, and RSE. Okay, series. Okay, RSE, series field resistance, and also we known as a series winding resistance. Okay, so we are here series field resistance. Okay, uh, name given is series field resistance, RSE, series field resistance stance, and also series winding resistance, winding resistance. Okay, there is two names of RSE. Okay, series field resistance and series winding resistance. Okay, so power drawn from supply means VI. Okay, and mechanical power developed, PM. Okay, power input, PM means mechanical power, and is equal to power input minus losses in armature and armature field. Is equation is VI minus I square and RA, armature resistance, plus series field resistance. Okay, in bracket. Okay, as I showing in this video. Okay, and I in bracket V minus I, and in also एक also one bracket in RA plus RSE. Okay, and two bracket incomplete in at the last, and is equal to EBI. Okay, back EMF current. Okay, okay, so next is shunt wound DC motor. Okay, this is topic shunt wound DC motor, and this is shunt wound DC motor figure. Okay, so the theory is the shunt means parallel. These motors are so named because they basically operate with field coils connected in the parallel. Okay, connected in the parallel with the armature, and the field winding consists of the large number of the turns of comparatively fine wire, so as to provide large resistance. Okay, as to provide large resistance, the field winding the field current is much less than the armature current, sometimes as low as 5%. Okay, I am write this. The shunt means parallel. Okay, shunt means parallel. This motor are so named because they basically operate with the field coils connected in the parallel with armature, connected in parallel with the armature, the field winding consists the field winding consists the field winding consists of a large number of turns of comparatively the number of large turns of comparatively fine wire, so as provide large resistance, so as to provide large resistance the field current is much less than the armature current, the armature current as low as 5%. Okay, in this figure we have defined the shunt wound DC motor. Okay, so the shunt means parallel. Okay, these motors are so named because they basically operate with the field coils connect in the parallel with the armature. Okay, the field winding consists of large number of the turns of comparatively fine wires so as to provide large resistance. Okay, the field current is much less than the armature current as low as 5%. Okay, and this is figure. So in this figure the current is supplied to the motor is divided into two paths. Okay, one through the field winding and second through the armature. Okay, I'm write this. The current supplied to the motor is divided into two paths. First is field winding and second is second through the armature. Okay, the current supplied to the motor is divided into two paths. First is field winding and second through the armature. Okay, so that input line current IL line current, okay, is equal to IA plus ISH. Okay, ISH means shunt field current. Okay, shunt field current. Okay, and armature current. Okay, as we know, and where IA is the armature current, IA is the armature current, and ISH is shunt field current, okay, and current and is given by expression ISH is equal to V upon RSH. Okay, ISH is equal to V upon RSH. So V is supply voltage, V is supply voltage, and RSH is series field resistance. Okay, RSH is equal to series field resistance. Field resistance. Oh, sorry. Shunt field resistance. Shunt field resistance. 1 second. RSH means shunt field resistance. Okay. V means supply voltage and RSH means shunt field resistance. Okay. And ISH means shunt field current. Okay. Means shunt field resistance and shunt field current and supply voltage V. Okay. So where is I'm write this, where V is the supply voltage and RSH is shunt field resistance, okay, and back EMF developed in this, okay, and back EMF develop is EB is equal to V minus IA RA. Okay, back EMF develop EB is equal to back EMF V minus IA RA. Okay, the power drawn from supply means P is equal to VIL. Okay, and mechanical power develop PM is equal to power input minus losses in armature and shunt field. The equation VIL minus VISH, ISH means shunt field current, minus IA square and RA. Okay, this equation will be make, and VIL in bracket minus ISH, complete the bracket, minus IA square RA. Okay, and VIA minus IA square RA is equal to IA in bracket V minus IA RA, complete the bracket, is equal to EBIA. Okay, so back EMF develop EB V minus IA RA, power drawn from supply means P is equal to VIL. Okay, and mechanical power develop PM, mechanical power input minus losses in armature and series field. Okay, VIL minus VISH minus IA square RA is equal to V in bracket IL minus ISH in complete the bracket and minus IA square and RA. and last VIA minus IA square RA is equal to IA in bracket VIA RA in bracket complete is equal to EBIA. Okay, so this is complete of shunt wound DC motor. Hello. So last motor is compound wound DC motor. Okay, so the compound wound DC motor has both shunt and series field coil. Okay, a compound wound DC motor has both shunt and series field coil. The shunt field is normally the stronger of the two, has more ampere of turns. Okay, and the compound wound motor has two types. The first type is cumulative compound wound motor, and the second motor is differential compound wound motor. Okay, so the first is cumulative compound. In this motor has two types. Okay, two types of motor: cumulative compound wound motor and differential compound wound motor. Okay, so first is cumulative compound wound motor. So I am write this again: cumulative compound wound motor. Okay, so in this is figure, this figure is cumulative compound wound motor. Okay, and this is differential compound wound motor. Okay, please see this. Okay, so first we talk about cumulative compound wound motor. Okay, so cumulative compound wound motor, one in which the field windings are connected in such a way that the direction of flow of the current is same in both of the field windings as showing in figure. Okay, and in this motor this type of flux due to series field winding strengthens the field due to the field winding. Okay, I'm write this. Okay, so we are right here, one in which the winding are one of which the winding are connected in such way that the direction of flow of current is same in both of the field winding as showing figure, as in figure in the motor of this type of flux due to series field winding strengthens the field due to the shunt field winding. Okay, so I'm write this is figure, and the two types of compound wound DC motor. The first is cumulative compound motor. We are talking about this motor, cumulative compound wound motor. Okay, so one in which the windings are connected in such way that the direction of the flow of current is same in the both of the field winding as shown in the figure. In this motor, this type of flux due to field series field winding and strengthens the field due to the shunt field winding. Okay, so second motor is differential compound wound motor. Okay, first we saw in cumulative compound wound motor. Okay, and this is a this cumulative compound wound motor figure, and this is differential compound wound motor. Okay, so theory is the differential compound wound motor is in which field windings are connected in such way that the direction of flow of current is opposite to each other. Okay, in the two field windings as shown in figure. In this type of motor, the flux due to series field winding weakens the field due to shunt field winding. I am write this. The differential compound wound motor is in which the field windings are connected in such way that the direction of flow of current is opposite to each other in the two field windings as showing in figure. In this type of motor, the flux due to series field winding weakens the field due to shunt field winding. Field due to shunt field winding. Okay, so the differential compound wound motor is in which the field winding are connected in such way that the direction in flow of current is opposite to each other in the two fields winding as shown in figure. In this type of motor, the flux due to series field winding weakens the field due to shunt field winding. And the compound wound DC motor, like compound wound DC generator, may be either long shunt connected or short shunt connected. In the long shunt connected, the compound wound motor series field armature are connected in series with each other in parallel with shunt field. In short shunt connected or compound wound motor, the armature and shunt field are parallel with each other and the pair is in series with the series field. Long shunt connection sometimes result in simpler wiring, changing from long to short shunt, or vice versa, has little effect on motor performance. Okay, okay. The I'm right here. Compound wound DC motor, like compound wound DC generator, may be either long shunt connected or short shunt connected. In long shunt connected compound wound motors, series field and armature are connected in series with each other in parallel with the shunt field. In short, shunt connected compound wound motors the armature and shunt field are in parallel with each other and the pair is in series field. Okay, the long shunt connection sometimes result in simpler wiring and changing from long to short shunt or vice versa has little effect on motor performance. Okay, I am explain this. The differential compound wound motor. So the differential compound wound motor is in which the field windings are connected in such a way that the direction of flow of current is opposite to each other in the two field windings as shown in figure. The winding weakens in this type of motor, the flux due to series field winding weakens the field due to shunt field winding. The compound wound DC motor, like compound wound DC generator, may be either long shunt connected or short shunt connected. In long shunt connected compound wound motors, series field and armature are connected in series with each other in parallel with the shunt field. Okay, and the short shunt, here is a long shunt and here is a short shunt. The short shunt in short shunt connected compound wound motor are the armature and shunt field are in parallel with each other and pair is in the series field. Okay, so the long shunt connection sometimes result in simpler wiring and the changing from long to short shunt or vice versa has little effect on the motor performance. Okay, so here we are completing the complete video of the types of DC motor. So 5 motors are included. The first is PMMC motor, so permanent magnet DC motor, separately excited DC motor, and series wound motor and series shunt wound motor. And the 5 motor is compound wound DC motor and its two types, differential compound motor and cumulative compound wound motor. Okay, so compound wound DC motor, there is two types we have discussed. First is cumulative compound wound motor and second is differential compound wound motor. Okay, so our types of DC motor is completed. So thank you very much, have a nice day. Okay, so if my name is Bhavesh, and if you like my video, if you watch my video, so please like and subscribe this channel. And next topic we will be okay, thank you, we will be back with new video. Okay, so goodbye and have a nice day.